Welcome. Today, we're going to make sense of function composition. So when we use the phrase function composition, what do we mean by that? We perform a function composition when we substitute one function into another function. Now let's illustrate this idea. So let's consider two functions. Our first function, let's call it f of x, and we're going to define it as x squared plus 3. And our second function, let's call it g of x, and we're going to define it as x minus 5. And now let's say that we want to substitute the function of f of x into g of x. The way that we're going to perform that is, let's look at the function that we want to plug into, which in this case is g of x. And now let's identify all the variables in this function, which fortunately we only have one, which is just x. And what we are going to do, we're going to take a look at the function of f of x, and every time we see a variable in g of x, we're going to substitute it with the function of f of x, which in this case is x squared plus 3. So now instead of having x minus 5, we are going to get x squared plus 3 minus 5. Notice that this is the same function as g of x, but the only difference is that instead of writing the variable of x, we are substituting the whole function of f, which in this case is x squared plus 3. And now we can simplify this expression. We'll have x squared plus 3 minus 5, which we will have x squared minus 2. And what we have now here, this is the function that we can obtain when we substitute f of x into g of x. And we have notation to represent this idea. Notice that the function that we substituted towards to was g of x, and the function that we substituted was f of x. So we can represent this idea as g parenthesis f of x, where the inside parenthesis is what we substituted. And the function on the outside is where we substituted to. So we can say that the function of f of x was substituted inside the function of g. Another notation that we have is what we call the composition notation. And this composition, we read it from right to left. The function that we substituted was f of x. So I'm going to write that function on the right-hand side of a little circle. Now that circle is not of multiplication or a value of 0. That's just a notation. And the function that we substituted towards to goes on the left. So if we read this notation, we can say that the function of f of x was substituted into the function of g of x, which is what we have shown here. So now let's say that we want to go the other way around. Now we want to substitute the function of g of x into f of x. Let's take a look at the function of f of x, which is where we're going to substitute it to, which we have it here. And let's look at every single variable in this function, which we have it here. And what we're going to do, we're going to take a look at the function of g of x, which is x minus 5, and we're going to substitute it on the variable of f of x. And when we do that, we're going to get x minus 5 squared plus 3. I want for you to realize that this expression is the same as the function of f of x, but we substituted the variable of x with the whole function of g. And in this case, let's not simplify. Let's just leave it as it is. So now this equation that we have here, it is the result when we substituted g of x into f of x. And the notations that we could have used is f parenthesis g of x. Because here we're saying that the function of g of x was substituted inside the function of f of x, which is what we have done. And another way that we could represent this is by using the composition notation of g of x on the right, composition f of x on the left. This notation, we read it from right to left. So here we're saying that g of x was substituted into f of x, which is what we have done. Let's take a look at one more example. So now we're given two functions. F of x is 3x and g of x is 2x squared minus 5. And the first thing that we want to do, we want to find the value of f parenthesis g of x. This notation is saying that we're going to take a look at the function of g of x, and we're going to substitute it inside the function of f of x. So let's take a look at the function that we're going to substitute it to, which we have it here. Let's identify all the variables, which we just have one, is just x. And what we're going to do, we're going to take a look at the function of g of x, and we're going to substitute it on that variable. And now we're going to obtain 3, but instead of writing x, we're going to write 2x squared minus 5. This expression that we have here, it is the same as the function of f, but we are substituting the function of g of x into the variables of f. And now let's simplify this expression. We can distribute, and now that becomes 6x squared. And we can distribute, and now that becomes negative 15. So we are done. Now we can say that f parenthesis g of x, it is equivalent to 6x squared minus 15. But we could have also written this using the other notation. We could have also said that g of x composed into f of x, it is equal to 6x squared minus 15. Now let's take a look at the example on the right. If we take a look at this notation, we are saying that we're going to take a look at the function of f of x, and now we're going to substitute it inside the function of g of x. So let's start by identifying the function that we're going to substitute to, which is g of x. Let's identify all its variables, which we just have one. It's been raised to the second. And what we're going to do, we're going to take a look at the function of f of x, and we're going to substitute it into the variable of x. And now we're going to have 2, but instead of writing x, we're going to write 3x. We are substituting, and then we're going to have square minus 5. Convince yourself that this expression that we have here, it's the same as a function of g of x, but we are substituting 3 of x into the only variable of g. Now we can simplify this. 3x all to the second, that will be 9x squared. And if we distribute that too, we're going to obtain 18x squared minus 5. Now we can say that f of x into g, it is equivalent to 18x squared minus 5. We could also say that f of x composed inside of g of x, it's equivalent to 18x squared minus 5. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.